Hello everyone. Today we are going to talk about the ethanol metabolism. So the ethanol metabolism occurs in the cytosol and mainly in the mitochondria. Also the perioxysomes and the microsomes also participates in producing various metabolites in the ethanol metabolism. So now first of all, let us discuss the reaction that occurs in the cytosol. So in the cytosol, what happens? In the cytosol, the ethanol, after the consumption of the ethanol gets incorporated into the cytosols of the cell, and the ethanol will be converted to acetaldehyde. This ethanol will be converted to acetaldehyde by the enzyme alcohol dehydrogenase with the production of the NADH. And um, after the production of the acetaldehyde, this acetaldehyde will eventually go in the mitochondria. So let's revise again. In the cytosol, what happens? In the cytosol, the ethanol is converted to acetaldehyde by the help of the enzyme alcohol dehydrogenase, and simultaneously there is various reaction occurring in the perioxysomes and microsomes. In the microsomes, there is production of the reactive oxygen species, whereas in the perioxysome there is conversion of the hydrogen peroxides into the water. So this conversion of the ethanol to acetaldehyde by the alcohol dehydrogenase can be inhibited by the drug, that is fomepizole. So fomepizole is the drug that inhibits the alcohol dehydrogenase enzyme, which will eventually inhibits the conversion of the ethanol to acetaldehyde. So this is the drug. The fomepizole is the drug that is used in the acute ethanol intoxication. So this the conversion of the ethanol to acetaldehyde is inhibited by the fomepizole drug. So this acetaldehyde will eventually will go to the mitochondria, and in the mitochondria the acetaldehyde will convert it to acetate by the help of the enzyme acetaldehyde dehydrogenase. So the acetaldehyde dehydrogenase enzyme will convert the acetaldehyde to acetate with the production of the NADH. And here the acetaldehyde dehydrogenase is inhibited by the drug disulfiram. So disulfiram is the drug that inhibits the enzyme acetaldehyde dehydrogenase, that inhibits the conversion of the acetaldehyde to acetate. So the disulfiram will cause the disulfiram like reaction like nausea, vomiting, and it will increase the hangover symptoms, thereby the discouraging the alcohol consumption during the intake of the disulfiram. So what are the various other reaction that occurs during the ethanol metabolism? So in the ethanol metabolism, there will be the increased NADH is to NAD ratio, because there will be the increased consumption of the NAD plus and the increased production of the NADH. So NADH by NAD plus ratio will be increased in the liver. So it will cause the lactic acidosis. And lactic acidosis occurs due to increase of pyruvate conversion to lactate. So there will be the fasting hypoglycemia. The fasting hypoglycemia occurs due to decreased gluconeogenesis due to increased conversion of the oxaloacetate to malate. So in the fasting hypoglycemia, I want to emphasize more on the hypoglycemia during acute alcohol intoxication. So pyruvate and oxaloacetate are required for the gluconeogenesis. So this pyruvate and oxaloacetate are made unavailable by the alcohol intoxication, because there will be the increased consumption of the NAD. So there will be the decreased amount of the NAD plus and the increased production of the NADH. So the increased amount of the NADH will make the pyruvate and oxaloacetate in low quantity, and also the increased conversion of the oxaloacetate to malate occurs during the ethanol intoxication. So this will eventually increase the risk of hypoglycemia, mainly in the diabetic patient and those who have prolonged fasting during the alcohol consumption. The ketoacidosis occur during the ethanol consumption, there will be the diversion of the acetyl coenzyme A into ketogenesis. There will be the hepatosteatosis. There will be the increased conversion of the DHAP to glycerol 3-phosphate. The DHAP stands for dihydroxyacetone phosphate. So in the hepatic steatosis, there is increased conversion of the DHAP to glycerol 3-phosphate, and the acetyl coenzyme A diverges into fatty acid synthesis, which combines with the glycerol 3-phosphate to synthesize the triglyceride. So what happens? There will be the increased production of the NADH and decreased amount of NAD plus due to excessive consumption of the NAD. So there will be the increased NADH to NAD plus ratio. So this increased ratio will inhibit the TCA cycle, and this will eventually lead to increase amount of acetyl coenzyme A that is used in the ketogenesis, and ultimately the ketoacidosis occurs. So this concludes our video on the ethanol metabolism. I hope you understood this lecture. Thank you.